Okay. My note taker is here, so I think we're ready to go. So thank you everyone for joining this working group meeting. And as I mentioned in the email, today I'm going to be demonstrating the data to science in a platform that my research group has been working on um, to manage all those, drone data for agriculture applications. And I'm not sure how long it's going to take. After that one, I'm glad that Peter is here. We had a meeting 2 weeks ago to talk about the survey. So hopefully we have time. We're going to move that topic to finalize the survey so that we can send it out as soon as possible. So before we get started, anybody has any things that you'd like to mention or add to the today's agenda or coming agenda in the future? Okay. Hearing none, I think I will share my screen and I will start. So I'm not sure how many of you have heard this data to science in a platform before. This is actually partially funded by Purdue School of Agriculture and also USDA and AgPI seed grant. And this is the outcome. And essentially, um, it is open source, online platform where you can download your drone data, manage it, share it, visualize it, and analyze it, and etc. So this is the URL. This is an open to public. Anybody can create an account. So simply you just go to ps2.b2s.org. And maybe I can just start with here. This is how this landing page is going to look like. If you don't have an account, you can click sign up, give a name, email, then password, create an account. You will have to confirm your email because I don't want the machine to create hundreds of accounts using some kind of script. Plus, I have to approve your account as well. So, if you want to do this, right now you can visit this website. Let me just paste the link in the chat window so that you can actually create an account while I'm just doing this demonstration as well. And I will also try to approve your account while I'm doing this demonstration as well. So let me pull up my email onto another screen so that I can approve your account as soon as you guys actually create an account. But once you create an account, confirm your email, and one of our admins approve your account, then you should be able to log in. So I'm going to use my credential to log in, and this is how it's going to look like. So one thing that I like to mention here is that the main menu is at the top, homepage. This is going to be the page that you're going to look at. And when you create an account, you're going to see nothing because you haven't loaded any data set yet, or you are not added to any of the project. Once you create an account, I can add you to a couple of projects so you can play with. And my teams page is in a team management. You can create a new team. So by clicking this, I can give a name of the team, what is the description, and you can search by a name here. I'm not sure. Any Jennifer? Let me see. We don't have any Jennifer, but for example, if I just search by name, all the people will just show up by clicking, for example, here as selected, will be added to the team that we're going to create. Then you can also assign this specific team to specific projects if you want as well. I'm not going to create this one, but I'm going to cancel. Or, okay, I'm starting to see Nicholas. I just approved the account, so you should be able to log in. So let's do some the test. So I'm going to create a new team. Then egg biodata phenotyping working group. This is a working egg biodata phenotyping working group. team. And since Nicholas, you just added, I'm gonna add you to the team, then click done. Then now I just create a new AgBioData Phenotyping working group team over here. See, I just see Jennifer, your account, just added. So I can just search for Jennifer. Oh, why can I see it? Or Jennifer, you haven't confirmed your email yet, probably. But if you want to create an account so that you can follow through, just do it. Anna, I just approve your account as well. So let me just add you. Anna, which I'm gonna add you to the team. Let me try to find Jennifer one more time. Now I see you. I selected, but you got an idea. So I will just
Okay.
move forward. So anybody still want me to wait for you to create an account that so that you can add it to this team? Or this want me just go ahead? Oh, I'm starting to see Fabian's. I just approved the account. Probably you haven't confirmed your email yet. That's the reason why I think here. Now I see you. So Oak and Berku, Jody, Nick. Do you want me just go ahead? Or
But go ahead.
yeah, Berku. I just added CPR. So this is you probably. So
Yes, it is. Yeah.
yeah, you can see, I can just create a team and add this in a member. So this is team management. As you can see, I have multiple teams created. Workspace is the place where you can manage your project. So let's say I'm gonna create a new project, and you can actually search by an address. So let's say West Lafayette. Click enter. Then it will zoom into this location automatically. Then you can zoom in further. Let's say that this is the area that I'm just working on. Just draw a boundary. Then this is how you set, where this project boundary should be, etc. But I'm gonna just working on some of the example data sets. So let me just go to some of the example data set that I prepared. So that, you know, when you already have, boundary of the project is in shape file, you can simply, drag and drop, there as well. This is network drive, so it's taking a little bit of time, but it'll show up pretty soon. While I'm just doing it, I just approve, all your account. So let me just cancel, or even doesn't let me cancel. Give me a second. Wow. This is danger of, doing a live demo, I guess. Wow. Why this is, give me a second. Just want to make sure. Hey, let me just, go do this and again. Browse file, workshop. Example one that I have, project boundary.zip file. This is the one that I uploaded here. We upload, then they're gonna just, set this in a boundary automatically based on the shape file. So I'm gonna say AgBioData example project. this is an example project. And if you know the planting date, you can just set the date here and the end date. And I'm not going to do this. Then I'm going to assign this to AgBioData Phenotyping Working Group. Click Create. A new project has been created. And right now I have a lot of them, more than 200. I think I'm getting close to 300. But it looks like it doesn't show anything, but you see AgBioData example, project has been created. Or if you can just search by keyword AgBioData. So you can just search by this here as well. So since Oak, you created an account, and also I see Jody, your account has been created as well. So let me post, add you to this team. Then Jody as well. Okay. Um, then you create the project. Now you come back here and come back to this in homepage. You're gonna see in one marker. I have right now access to 267, so this is the reason why you see so many. But once you log in, you should be able to see that marker, over there. And what I want to do here is going in here. You can pretty much, everything that you typed in when you create a project, you can just, modify it here. I can also do the manage access. So click here. You see, and everybody is added as a viewer. But since you guys are working on this workshop or the tutorial, I'm gonna make everybody as an owner. Um, but please don't download any data yet because I'm gonna be downloading data. But you guys will have full control, whom to invite and etc. So coming back to this project, you can change the boundary of this project by clicking this one here. Click edit button. You can just modify it here. I'm gonna just do it, update the field has been updated. Just come back. Oops. Why is not being updated? Field updated, it says that. Let's go back. Oh, probably I need to check that. But anyway, from there now you can add a new flight. So let me just see the example data set that I was working with. Sample data set was acquired in 2022, July 25th. So I'm going to just here say that flight, I think a mid-season flight. This is acquired on July 25th of 2022. We can just set the altitude if you have that information. Let's say, I'm going to just type in any number here. This is an RGB sensor. Let's say this is an Phantom 4. Let's say, all the team member who has an access to project will show up as here. So I'm going to set Jennifer as in a pilot and click create. Now you just created the flight here. And I'm gonna add another flight because I also do have um, additional data before planting. This is gonna be June 24th, 2022. Let's say 50, 75, 75. Say, I'm gonna say, Berkeley, you're the pilot. I'm gonna add another flight here. Early season is gonna be June 23rd, 2022. Same thing here, 50, 75, 75. And I'm gonna just assign everybody a different pilot. So we just created this in a 3 flight. So once you create a flight, now you can upload the data products. So let's say mid-season flight. I want to upload the raw data. Just click upload raw data. Just zip everything in a single file, drop here. Then for a certain group of people that I assign to, you can even do data processing on the cloud as well. Don't have a raw data set here. I'm going to demonstrate this raw data processing on the project. So let me just go here. See peanut demo here. So let me just give you an example. Manage data here. You see there's no data product. There's raw data set being uploaded. there's a process button activated. Once you click this, we use a meta shape is in the backend. So you can just choose an RGB camera, multispectral camera. Multispectral camera is not implemented yet. Only just RGB can work, but you can set the align photo quality and build point cloud quality. I'm gonna set as a default. Click check to proceed, submit job. Now what is happening is this is being pushed to Purdue GPU cluster. They're doing processing over there. I will come back to this in the flight so that we can see generate data product. So if you just go to Peanut demo here, you see actual checking for progress. This will show what is the process of right now is 10%. It'll be updated over to 100%. That will point the push back to this workspace. But going back to this AgBioData, assuming that you already processed the data, click the data product. Now you can start to upload the data product. So you can upload the DSM point cloud, also, which is pretty much standard output from any of the structured point motion software. And if you have anything else, you can click other, give a name, you can upload there as well. But let me just upload the orthomosaic images first. So sample data for upload. I'm gonna upload orthomosaic RGB, click open, click upload, and it is uploading to the server. And I click done. Then now you see that new card is being created. What is happening in the background is that we upload this file, we convert everything is in a cloud optimized data format so that you can actually stream this data to any computing platform you want so that you don't need to download the data and use data set for visualization and data processing. So we just upload this service model. So we have, we don't have, we have a DSM here. And click upload. And I don't think I have point cloud. Let's see. Yeah, we do have point cloud as well. So click point cloud last file, and I click upload here. And done. We are also converting this in a point cloud into point cloud cloud optimized point cloud format as well. So they are actually in a general preview. So if you want to the next flight, oh, so this is before planting. So I think this is I put the date wrong before planting. Sorry, I can edit this information. It should be June 4th, not June 24th. So I'm gonna edit flight. It should be 04. Sorry, click update. So going into before planting, we can just do the same, upload the data product. I'm gonna go to additional sample data. And what am I choosing here? I'm choosing also again. Let's go here. Additional sample, June 4th in IGB, upload the file. Done. DSM. I'm uploading this file here. Done. I'm gonna also upload the point cloud of the earlier one. I'm gonna speed up the process. And June 23rd, upload the data product. Start with the DSM, which is this one. And point cloud, this one. Then also, you can also upload the multispectral also as well. And I'm just unloading an RGB just to give you an idea. Oh, you know what? Let me just unload the multispectral also for mid-season flights so that I can demonstrate some of the data processing capabilities. So let me just go back to the original multispectral, upload this file, done. So you guys kind of see that, upload process can be done in this way. So, good thing about this is now you have upload this, you can go back to homepage. Now you can search for same thing, AgBioData example. Now you click this in a project. Now we're going to zoom into that actual, project boundary. You can see this in a boundary on a, the mapbox layer. You can choose, different base map layer as well if you want. Now, if you want to see the actual data, click this in a for data product, the triangle, it will expand. It shows you all those, data product that's been uploaded. So you see this is an RGB orthomosaic, has a 3-band plus an alpha channel. Multispectral has a 5-band plus an alpha channel. Once you click this, I will see that this actual orthomosaic is being generated. So, okay, you have a question?
Yes.
Mhm.
You just uploaded data. Can you also upload data in bulk? So,
I'm going to demonstrate that we can programmatic upload using Python. So I'm going to show you, how you can do this later.
okay,
So
okay.
you can just zoom in. You see that as you zoom in, high resolution the mosaic is being rendered on the fly. And you can do different color rendering as well. So as I say, I want to do 3-2-1 instead of the 1-3 apply changes. Then you will see this color rendering is generated on the fly as well. Okay, but let me just go back to 1-3 because that's the natural color combination. And for the single band, if you click this, it just shows up with a single band with a color map rendered. So for that one, you can choose a different color map. For example, if I want to choose a jet, they just apply this one on the fly, and they generate this one here. As you zoom in, you're going to see high-res information being rendered as well. And you can do different color stretching. So I want to do a little bit more aggressive, color stretching you apply it, they're going to just end up being applied over here. Or if you want to use, specify, the min max value. Example, I know this is in a very small number, but let's say 182 apply changes, then it will look kind of very kind of pale because you're expanding your color map to be a lot, the larger, the range than what it is. So you can just come back here, save it. If you want to save this as a default view for you, then you can click Save Changes. And the point cloud, if you click this, you can actually see this in a 3D point cloud, visualizing over here. You can zoom in and out, and you can do this measurement using, basically in a Pottery toolbox. If you would like to do length measurement, height measurement, if you want to do some, for example, I don't know, profile here, okay? Then come back here, scene, show 2D profile. I think Chrome is not working properly, but I think Firefox will render, properly. It will show you the point cloud 3D profile on this view as well. So going back to this project again, now you can visualize all this data very very easily. So this is early season, and you can just filter out this the before planting. If you want to do compare the side by side, there is a button here at the top. Clicking now you can choose different flight. I want to compare, let's say that, early season and late season. So you want to zoom in, you can just do slide bar so they can go back and forth. And you can also do, for example, DSM comparison over here so that you can see how much, growth has happened, etc. And one of the cool features here, let me go back to the single view, choose, auto mosaic here. Let's say that I like to share this data with others. Now you don't need to send this file. If you scroll down at the bottom, there is a share button. If you click this, another pop-up window show up. Now it's restricted, meaning that only you and anybody you added the project can actually access this data. But if you click anyone and copy share URL, and let me open up a private window. If I paste that link in this window, I'm not logged in, as you can see at the top, but that person who has the link actually see this in the data. So like you're sharing your Google Docs with others, you are not sending the file, you are sending the link. You can send this link to others so that people can actually see the data set without creating an account or downloading any data set. And if you want to actually let the other person to download this file to their local machine, copy this URL, send this link, then the other person should be able to download it to their local machine, which I don't recommend to do it because the whole idea of this in a platform is that we like to have everything in a centralized place that you should be able to stream this data set to whatever company platform that you need. So I'm going to go back to restricted. And you can do the same thing for DSM. You can share, if you want to share a point cloud, for example, coming back to this project, AgBioData. If I open up this missing flight, you have a point cloud here. There is a the lock icon here. Once you click this, same thing. Click anyone, copy share URL, open up. Sorry, open up the private window. Paste the link. Again, like I said, I'm not logged in, but the person can actually visualize this in a 3D point cloud without creating an account. And if you want to send the URL for them to download, copy this and send this one back. I'm gonna come back to this in restricted. So this is a basic visualization and sharing features. And there are some additional features that you can do. For example, let's say I'd like to do some vegetation indices in a calculation. For RGB, there's a toolbox button. We can generate the excessive greenness index. So if you just click here, it specifies which one is red, which one is green, which one is blue. Then click stop button. Then coming back here, and you will see that the EXG is being generated on the server side. Once processing is done, this becomes available. As you can see, click view. Now you can see this in the EXG value. Let me see. This is set to be min max value, which is usually this is way more aggressive. So I'm gonna set to 0 to 1. Apply changes. Then use in a different column map example, so that you can just do this at a vegetation. This is a calculation on the fly. Coming back here, again, AgBioData again. If you choose a multispectral band, which is this one here, toolbox. Oops. Oh, sorry. Oh, I set this as an the RGB. That's the reason why. Sorry. So what I need to do here is, coming back here, I need to edit flight. NDBI is going to be only available from multispectral. So I changed it to the multispectral manage data. You click toolbox, then now you see the MDBI shows up. Which one is in a red band? I believe this is 3. Near infrared is in a 5. But yeah, all the sensors in a different spec. But for example, I click this, same thing will happen. NDBI computation isn't happening in the back. Now it becomes unavailable. Click view. Then now you can see this in NDBI, generated as well. Okay, I don't have a plot boundary added over here, right? But let me just go back here. Let me just show you some of the other example where you can do the journal statistics as well. So let's say I'm gonna generate. We already have an EXG, generated for this. This is in a width crop here. We can also upload, vector data on this platform. The way how it works is that, let me show you how you can do this. AgBioData. If you click in a flight, this is what you see. You can also add map layers, add new map layers. Simply drag and drop either zip shape file or GeoJSON file need to be uploaded. And the condition here is that everything need to be set to WS84 latitude and longitude, EPSC 4326. Once you drag and drop this, it will become available. But coming back here, going back to Cornell example that I was showing you earlier, choose EXT. Oh, this is the one that I generated. I didn't set the column map properly. Once you zoom in, let's say if you click this in the plot boundary, you see that the boundary has been generated. When we click this, these are all the attribute that was added when you upload this in a shapefile. But they are doing journal statistics for this in a specific plot for the layer they are visualizing. So what is a mean value? What is a maximum value? What is an average, median, standard deviation? How many pixels in there? And this is summarized here. You can download this in a CSV file. You can download it GeoJSON. You can do the further analysis. But what if you want to do journal statistics for the whole plot? What you can do here is coming back to this Cornell project that you're working on. I'm gonna choose this manage data. Let's say this EXG is the one that I was working on. Click toolbox. You see this journal statistics become available. I already ran this journal statistics using this vector tile uh, for this specific layer. So you can just download it but for example, if I want to just run journal statistics for another layer, click start, and it'll be running this journal statistics in the background. Once processing is done, this download CSV file will be available. You can just download it to your computer, or download your JSON and load into any of the GI software to do any further analysis if you want. Okay, I think that is very basics of how to use this data to science platform. And the beauty of this platform here is that, like I mentioned earlier, this can be coupled with any of other computing platform of your choice, as long as that computing platform knows how to consume this in a cloud optimized data format. So I'm going to give a demonstration of this in a QGIS project. QGIS software. This is another open source GIS software. Anybody can download for free. Don't worry about these error messages. Once you load up, go to plugin, manage your plugin. Then let me just show up here, choose all and search for D2S. And we published a D2S browser plugin. So I already installed it. So it says reinstall plugin. But for your case, if you haven't installed it yet, it will say that install plugin. So just click it. It'll install the plugin. Once you have that one installed, come back to this plugin, D2S browser, click this button here. We'll give you a pop-up window. Simply type in ps2.d2s.org. And in order for this D2S browser to work, what you need to do, I think there's one thing I forgot here, is that because everything that I showed on this in a web is authentication is done by JWT token. So technical detail you don't need to know, but the QGIS doesn't know how to use a JWT token. So we need to have some form of API key so that we can authenticate who you are. So by default, your API key has not been generated. I think I need to change my API key later because this is being recorded. But if you click your name, click your profile, then this becomes your API key. So anybody who has this key can act as you. So by default, you're gonna see that you're gonna see something like this. Your API key has not been generated, and you need to click this and request an API key so that you can actually generate this an API key. Then this D2S browser programmatically grab this API key and use this key to log in inside the QGIS. So after this one, I'm gonna change this one to something else so that nobody can actually log into my system. But you have a question?
Yeah. Do you also have a manual somewhere where this is described?
Well, I have a documentation page, which I'm gonna to share with you later.
Ah, great, great.
So
Thanks.
you need to have this an API key generated, and otherwise you're gonna be able to actually log in QGIS. But once you have created this an API key, type in your email and password. Let me just go here. I don't remember my password anymore, so copy it here, paste it, click login. Now everything is now you just log in, your project will be populated, in a flight will be populated. So if you choose an AgBioData example project, you see that 3 flight they just created over here available. I'm gonna choose first and a flight here. I'm gonna say I wanna add this in a two also. I think one is a multispectral, one is an RGB. Let me just add them all. Okay. I selected the map. And what is happening here is that now you are streaming all those layers from data to science to QGIS. You haven't downloaded anything. You're streaming it. And it becomes available. Everything becomes available over here. At this moment, everything is same as GeoTIFF file in your local machine. So now, for example, if I do this in multispectral, you can do the multi-band display. So 512, I just apply. You see that, color infrared, the color composite is, being generated over here. And we also published a plot boundary plugin. So if you go to Imagine plugin, search for, plot boundary, you can just install this in a plugin over here. Then you can just enable this, which base layer that you want to use to create the boundary. You can just set as, the location to be, I'm going to just save it as T, any file, get upper left corner here. What is in a plot width? Uh, let's see, width is going to be 3 meter, 1 meter, row spacing is going to be 30 centimeter, 5 centimeter, 50 centimeter, rotation angle to be 45 degree, and click generate. Oh, you see oh, I just did only one by one. So 3 by 4, I'm going to do -45, click generate. Then you can see, this is being generated. We can just do this on the fly. So let's say it should be -2 degree, something like this. Okay, click OK. And you can do the journal statistics on this QGIS, or you can upload this in a plot boundary to, D2S, journal statistics from the, data science. You can just do whatever you want. Okay, but the beauty of this is that now you can stream pretty much any data set you want. So let me just log out. This is not an example related to agriculture, but to demonstrate that you can actually stream very large files. This is one of the largest orthomosaic images that I have ever created. So this is actually orthomosaic images in rainforest in Amazon and Ecuador. You just click add selected map. This is about 170 gigabyte in size. And you see how quickly it just showed up. And if I just zoom in to this area, now you see that it looks like kind of the raw resolution. What is happening is that they're trying to stream the higher resolution of this region they're looking at. So you see that it shows up right away. So exactly the same way, whenever you want to watch any video from YouTube, you don't download the video, you stream the video, you skip to the middle, you just stream from the middle and etc. This is exactly the same technology here. Now you don't need to download this in a big GeoTIFF file anymore. You can stream this into whatever computer platform you want to use. And if you want to do any local data processing, either can clip this part into your local drive and do the data processing. But the better way of doing it is going to be something that I'm going to demonstrate later. So this is QGIS plugin that you got. Just exit out. And if you go to pi.d2s.org, this is actually a Python module that we are publishing. So all you need for you to be able to access this and everything that I showed you in this Python environment is that pip install D2Spy. So I highly recommend you create a virtual environment from inside the virtual environment, install this D2Spy by doing a pip install. And there are some example how to install guide. There's some example Jupyter notebook that we uploaded over here. We have a full API reference and available here. And to give you an example here, let's say I like to clip the rest of the data. So we have an example code here. Simply run this code, then log in here, get the project by title, then get the flight filtered by date, and once choose the data type, which is in the DSM, then you can get this in the map layers. Then you can just actually do the clip. So you just see clip features is search, and the clipping part is where is it happening here? I haven't looked at this code yet. Duration. I think the clipping part is missing in this code. Yeah, there's going to be additional, the line that you can do so that you can clip this in a GeoRaster, the GeoTIFF file, and save it to your local, file as well. I'm going to update this, but, coming back here, let me just show you some of the real example. So let's say visualize your project using a leaf map. So click here. We have an example. You can run this in a Jupyter notebook in your local environment. The even better thing is you can run this on Google Colab, which is free Jupyter notebook environment Google provides. So if you click this on a button at the top, This Jupyter Notebook will open in Google Colab. I'm going to connect to one of their instances. Since this is a virtual machine, they don't have Deep2Spy and Leaf Map, which is the module that we use to visualize the data. Is not available on this machine. So then I'm going to install these packages, run anyway, but then installing this Deep2Spy and Leaf Map module over there. Okay, they are installing right now. Second. Once you install these packages, now you can load all the required module here. Now then that you can log in using the approach that I mentioned earlier. Okay, type in the server address and your email. Then I'm going to log in and it'll ask me a password. So again, one more time, my password. Copy password and paste it, enter. Now you're logged in. Now you get all the project programmatically. And essentially getting the centroid of the project and store them in that data list, convert it into pandas data frame, and I just simply plot this centroid on um, this in a leaf map layer. So the exact same screen that you saw from this website, I just recreated exactly the same thing in this Jupyter notebook. But the thing is that you can now stream all your raster data in this Jupyter Notebook environment. You can do this in a further data processing here. So you have a lot of flexibility in terms of whatever you want to do. And the last piece that I want to talk about here is that now we also have stack service being provided for this one. This piece is not integrated into our ecosystem yet, but later what we are working on here is that for any of the data product or any of the project, you should be able to publish your data set to this stack so that others can discover this data and all the metadata and available, URL to your, the cloud optimized data format and etc. Then they should be able to grab that information, plug into any of the computing platform they want to use to for the data analysis and etc. So good thing about this here is that you can do spatial temporal query. So we don't have any D2S data set integrated in this one, but we do have all USGS 3 depth, which is an airborne LiDAR data set available, plus other geospatial data. So let's say I like to find the data set available over here in Dallas. Zoom in here, click submit. Then they will show you, hey, we found this in a specific data product. We have USGS Studio LiDAR data available from acquired in 2018 over this area is available. Click this. We have all the metadata shows up over here. And this is an end-to-end data format. If I want to copy this in URL, then go to Google Cockpit Viewer and open this up and simply add the data, paste it. Now you can actually see there's a lot of noise that once you start to zoom in, you'll start to see higher point density, point cloud will start to show up. So you can see all those, I think that this looks like kind of power line. But this is in a beauty of cloud optimized data format. You don't need to download the data. Once you know how to discover it, now you can consume this data in any computer platform of your choice. So currently we are working on the you be able to publish your the data collection in this stack so that others can discover and use for the analysis. So I think I'm going to stop here. This is a very quick introduction of data to science platform that my group has been working on. I'm happy to answer any question you might have.
Yeah. Well, great presentation. Thank you.
Mhm.
Uh, I just noted a few questions. We're working on some drone data. We have drone data from two potato fields in
Hmm.
Holland,
Hmm.
where we flew every week for the
Hmm.
last 4 months.
Hmm.
It was an experiment in to measure the drought,
Hmm.
the effects of drought. Unfortunately, this year we had the wettest season in the last 10 years. But so we have a lot of drone data. So I'm really happy to tell my the researchers here to use this.
Hmm.
So two questions on that. So one is, what about the metadata? Can you fill in somewhere, for example, the variety of the crops or the treatments, or is that all outside of the platform?
So we don't want to implement everything in this environment, but we like to make this the platform accessible so that you can feed this information to other company platform to do exactly things that you described. So, for example, we can use an QGIS plugin to delineate the plot boundary that will generate a shapefile. You might already have fill in at the layout design in Excel spreadsheet or whatever. You can easily join the table with your already existing the database with the shapefile. Then this shapefile has all the attribute that you need. Then you can unload that shapefile back to the D2S where it becomes available from anywhere. You can do the journal statistics and etc. So we are currently working on developing a Jupyter notebook examples to show you, you create a plot boundary, then how you can merge, this other, the field layout information that is in either CSV file format or in whatever format you have, and merge into, your plot boundary, then, being unloaded into the data science to do any further analysis.
Mhm. All right. And so it's both aimed at well, more data around crops, for example, but also around forest.
Yeah.
Because I'm also advisor to a rainforest reservation project in
Mhm.
Costa Rica,
Mhm.
and they're really eager to use drone data there.
Yeah. So
So,
I mean, I only showed a fraction of the data, but I do have a lot of actually, forest data set as well.
cool.
Ecuador data set is the one that I showed you earlier. This is a
Hmm.
part of the X Prize in a rainforest competition that I participated. We also have in Costa Rica OSA research station. Are you familiar with this location? And we do have OSA data available here. We have multispectral data collected over 200 acre. We do have LiDAR data collected so they can actually visualize this location here. Then I
Nice.
believe we also have DTM hue shaded layer as well. And there's a lot of this can work with any application. So essentially, this is a platform that can handle any type of geospatial data stored and managed. This is an AgBioData working group, so I mainly focus on agriculture application, but this can be used for others as well. And I think you have some questions.
Yes, thank you very much for your
Mhm.
presentation. This is very helpful, and thank you for building all of these tools
Mhm.
for researchers. I just have a question. Are you kind of like planning to give workshops on this, or because I am affiliated with AF Farms here,
Mhm.
and I know that researchers here have a
Mhm.
lot of drone
Mhm.
data, but they also have multispectral and hyperspectral
Mhm.
data. And then we also have like sensors in the field. And I
Mhm.
assume that this platform would work with also like sensors in the field data that can be visualized.
I mean,
And and so and like just kind of like and I'm kind of like curious, I mean, kind of related, but maybe not. Maybe this is a separate question. Like, you have mentioned the standard that you are using for geo coordinates, and that totally makes sense. And do you find that this standard is good to use for geo coordinates in general, or you are using it because you think it's used a lot? And I am asking this question because right now we are kind of like trying to discuss like what kind of like standard to adopt for like geocoordinates data.
Mhm.
And like, you know, kind of like trying to convert our data sets to ML Commons format. And so, yeah.
Yeah.
So this is kind of like
To answer your first question, Anna, you are located in Urbana-Champaign, right?
yeah.
I'll be more than happy to travel to your location, give a workshop. I do workshop a lot. I actually gave a workshop in Forge North America, free and open source software for geospatial conference in North America. I mean, in St. Louis, a couple of weeks ago. I recorded this, workshop, make it available in our YouTube channel. I also had probably Jennifer, Philippe. And I had a collaboration with the Philippines group because that they have a field image R the software to do all this phenotyping. They integrated their computing or algorithm in QGIS. We already have QGIS in a plugin, so I did a workshop and with them to demonstrate how to pull the data from D2S to QGIS and using field image R to all those phenomic analysis. So, we are doing, did that workshop. But Anna, if you have any opportunity you want me to invite there and give on a workshop, I'll be more than happy to be there and give a workshop to those in the audience. I think
Fantastic.
that's the answer to your first question. Second question is that by no means we want to create any standard because standard is hard, and is everybody want to have their own needs. So the approach that we are taking here is that instead of we come up with a standard, we make this platform as flexible as possible. So make it accessible, make it discoverable so that let's say, one group has, one standard, they need to follow, but they still programmatically, write a code to convert whatever data set from this D2S to, be compatible with, their standard, etc. In terms of, the geospatial coordinate that I showed you earlier, that is when you're uploading this in a plot boundary, map layers. I just set the, WGS34 because the backend we use in a leaflet, in the front end actually JavaScript library we use expect this layer to be WGS84, but we can easily write a intermediate converter where if this is not WGS84, we just convert this into WGS84, to be compatible. But the point here is that you don't have to upload this data in WGS84. You can upload in any coordinate system. And we have the backend system where we check this and make sure that that coordinate system is going to be actually referenced to the global data, so you can overlay multiple layers as well.
Okay.
That said, I think WGS84 is like the standard, generally speaking. Unless you're doing something crazy with astronomy or something like that, for most software, most geocoordinate systems, that is the default standard.
Okay, that's helpful. Thank you.
Yeah. Only thing I want to be careful is that for those of the people who doesn't have this geodesy in the background, WGS4 requires a lot of decimals to keep that precision. So I think that there's an advantage of project coordinate system like in UTM or in any of the step-line coordinate system where all the units is in either meters and feet, where you only need to keep a few decimals. Versus WGS34, in order for you to keep that the centimeter accuracy, you need to have at least I think 8 or 9 decimals to be kept when you're reporting your coordinates.
Yeah. Okay. Thank you so much.
I'm also working with wheat breeders. I gave you an example of the wheat field over there, and Peter, you might be aware of Cornell T3 group, Jean-Luc. We are working with them.
Yeah,
That all the phenomic data, drone phenomic data is stored in this platform. We have a programmable way of pulling this information from D2S, and the T3 also I think is using a B base in the back. So they do have API call that we can make to pull all those information. So we are currently developing a use case where people can pull phenomic data from this platform and pulling all those field layout and the genomic related information from T3 database so that they can integrate this phenomic and genomic information to do advanced analysis as well. So
yeah, I didn't know T3 was involved in this, but I like it's cool to see they're involved, and I'm gonna recommend a few other now that I've seen this, I'm gonna recommend a few other groups at Cornell here to get involved. So.
And I'm currently developing a proposal that I'm planning to submit to USDA DSFA is called in a program this November, and essentially develop a proof of concept use case scenario working with a national breeding program. The program that I'm working with is in a maize because I'm in Indiana. Corn and maize is one of the major crop. So I'm working on the proposal right now, working with the G2F, the group who has historical drone data set already being collected, and make this data set available on this platform, develop data processing pipeline and etc. One good thing about this is that now everything is being processed in the same pipeline, so that you have some kind of the confidence that the data quality is going to be at the same quality. Because a lot of times you just get the data product, you don't know how this data product is being generated. But as long as we have this in a standard platform where everybody is in access to, they can just use this same the data processing procedures. Then they can expect basically you can compare the result from one location to another in a very the fair comparison.
Okay.
Okay, I
Thank
think
you.
I'm sorry, Peter. I thought that I'm gonna have enough time to demonstrate, and we can talk about this in a survey, but probably we have to, postpone that in a survey discussion in our next meeting. Hopefully, this introduction was useful. And in the meeting, quick announcement. The next meeting is in the middle of IPPS conference, so I think I'm gonna propose to cancel that meeting, so that I know a lot of people here is going to be in that meeting. So we are not going to meet in 2 weeks, but we're going to meet in 4 weeks. I will send out an email. Thank you, everyone. I will
Thank
see
you.
you in the next
Thank
meeting.
you.
Okay. Thank you very much.